Okay, thanks. So, well, we are running a little bit out of time. So what I was thinking is to send you three keywords. And I will go a little bit through them, and then I will just come back to them. So, okay, one is content generation. This is what we do. We want to have playable content. We want to customize our generation, and we want to be able to control and understand bias. Okay. You probably know of Genie. Okay. So this is practically, it's content generation in which you can have some interaction with what you're using, right? You can indicate if you want the camera to move up and down, or you can put in some text, and then you are going to go through the scene according to the text that you have. Okay, that's fine, but still, I believe there is some limitation. So what about generating something like this, right? So there, what you have, you just learn from the data, and you learn what is to play tennis. Okay, so you have two tennis players, you can put in some text information, so you tell what each of them is supposed to do, and then you just generate your. And then what I will show you, you can also play the director, you can also tell what is the outcome of the game, and you can tell who is going to win, you can tell what kind of actions these particular players are doing. Okay. So we have, in order to do that, we have two components. So one, it's a synthesis model, right, in which we are synthesizing what we have in there, and we have the animation. I don't go into many details because I don't have enough time, so you can have a look into our paper, but I will just tell you the high-level ideas. So the first part, of course, you need to kind of try to understand how you translate a particular text command into what you're going to animate in there, right? So you can say, for example, a player will not catch the ball, which will be related to the fact that the other player is going to win the point, right? So that's these kind of things are related. And then what you do in an iterative way is try to divide the action so that what the player will do according to what the other player is doing. And it's not only the player here, but it's also the ball, so that the speed of the ball and so on. So what we do in the synthesis part, so we have a nerve-based system in which we are rendering the state of the environment from a given viewpoint. And of course, we have a composition of nerves, so one for each of them. And then in the end, we are just using L2 and perception reconstruction losses in order to generate what you have. Right, so the object that you have, of course, in this case, it's just simple scene. You have the two players plus the ball. So in the animation, we just try to try to see what we do with these key players. So you have we have a diffusion-based approach. So we are producing sequences of states based on conditional signals, and the conditional signals can be values like the pose of the player. For example, when the player is serving or it's kind of doing the backhand or forehand, the pose is going to be different. You can have location, and of course you have the velocity of a player and of the ball. And then, you can have natural language, which is going to tell what the player is going to do. Right? If you think about it, it's kind of similar to the old phone games. The only difference here that you have real people, and you want, of course, I just want a player to just be shifted around. I want to be in the natural position, in that location, for that type of ball that is going to receive. Right? So if I'm doing a forehand, I'm going to open my hand. If I do a backhand, I have to put the other hand together. So both is quite important. Of course, the conditions are optional. Could also be generated directly according to what the user is saying, or could also be inferred according to what the action is going to be. Right. So if the ball is coming to the right, of course, I'm going to do a ball. And so And then, of course, we have the text that is using a standard T5, which including the next. And then we can also have a mask in which we tell if the input serve as a conditioning or it's going to be. And in the end, we just unwrap everything in the job that's again. So some examples. At the moment in time, you can control what you want to do. Let's say you control the pose. You can control the camera viewpoint. You can control the field. What you want, the style, what you have, and then once you have that, you can let it play, and then you can just play. Of course, somebody will say, yeah, but what's the point of having these two guys just looking around and playing forever? Well, I mean, what we do there, of course, you can also tell the user, well, you can control now what these guys are going to do, right? So it's kind of could be empathy. Right, so you can, in order to do that, you need to understand the physics and the game logic, and you can receive this action input expressed with that. And you can tell how the player is moving, right? Moving to the right, the left, and so on. You can tell how the ball is hit. I'm going to serve, I'm going to do the forehand, backhand, and so on. I'm going to tell where the ball is at. Back to the left, to the right, outside, whatever. Okay. You can also make a particular player win. And here I have two examples. So one is, let's say, original video in which the bottom player is going to lose. Like, for example, it's not going to reach to this ball. Then the other video is I have half of the original video, but now the conditioning is that I want that the top player will not catch the ball. So this means that the bottom player is going to. That's the same serving. It's exactly the same generated video, but now something happens, and now this guy it's returning along the line, and it's going to be right. So you can do the guarding here, and you can just make this type of. Right. So we have this playable game engine and video games, right? So you can tell you have the captions, and you can just play around with what can do. And in order to do that, we have a set of we have a data set in which we have can have 7,000. We have 7,000 sequences, different resolution, 15 hours of videos. We have annotated frames. We also have unique depth, right? So we were kind of looking through the game, and then we're putting depth in it. We also use Minecraft, so this is a real game engine in order to kind of test the system. Know that in the tennis play, we are not using 3D information directly. That's kind of, in this case, especially for this kind of camera, when you don't develop. And this is something that we try to look into now, right? To incorporate real 3D. We try to have some more complex interaction between actors and between the actor and the scene. Somebody was asking me, but can you do double tennis? Yes, we can, but there it's definitely far more complex because the interactions are more complex. Another problem is here, especially from this camera viewpoint, that you can have overlapping between. And that's a little bit more complex. In this particular case, with this viewpoint, you don't have this kind. Another important thing is customization. Right? So imagine now that you have a set of concepts. Concepts could be my cat, my dog, particular person. You can see Jan LeCun in there. You can have a particular style. You can have a particular template of motion. And what you want to do, you want to generate particular videos with this concept in. So you would have something like, I want that V8 concept, right? The man, Jan LeCun in that case, performing the V5 motion. So we are playing the violin under the system. And now it's just enough that I'm just changing LeCun with somebody else, and then I'm just generating it. Or I'm doing LeCun doing something, doing another type of motion. It's not always perfect that you see there is a duplication of his hand with someone after. Yeah, but let's see. Or you can have something more complex. You have two dogs. It's the first dog, and your dog, and they are just, running over the. So this is, to me, I think this is quite important, right? Because so far, usually the models are just, let's say, agnostic of this type of thing, right? But I think the users really want to do videos with their own, dogs, cats, whatever you want to do. Okay, so what we want to do, we also want to do it in a continual fashion. So we want to learn new knowledge over a sequence of stacks while preserving previous capabilities. And we want to personalize these visual diffusion models by fine-tuning with the user-provided visual references and text prompt to generate videos that reflect specific subjects and motion patterns. Right? So you can see there some examples, and you can go from single concept to multi-concept. These are some details, practically how we do. We have some task specific that is preserving the identity, right? So we want to have this type of concepts that are orthogonal, so they are not influencing each other. We have a task that is, we have a module that is looking into collaborative type of things, so how these two elements are going to influence each other. And then we have something that is controlling the top. Right? So I can even draw the trajectory, and then I can tell how this element into the video. We have a data set that is available. So with the 35 sequential customization tasks, in which are 20 subjects, 5 style concepts, 5 person concept, 5 motion concepts. So this is some of the examples. Maybe I should go to the video directly. Right, so you can see a single object like a cat exploring cardboard boxes in a cozy room. And of course here, the one in color, you can change this cat with another cat and then it would still work. You have the V20 doll that you saw before. Now it's performing this particular motion, whatever, and you can learn it. And you have a boy in a particular style, let's say, so you can see the style in there. It's kind of walking. Right, so you can do, and we are considering this as a continual learning approach because you can, of course, add in some more elements while I have a new dog and I have a new person that I want to add in there. And of course, I want to make sure that I'm not going to forget what I learned. Right, so this is the type of thing. And finally, what you want to do is to make sure that when you are generating content, here we are looking at images, we are controlling the bias. So that is where understanding the bias. Right, so you can see if you just take your favorite stable diffusion model, it is stable diffusion Excel. If you put a prompt like a picture of a person in the kitchen, for some reason you get, mostly female. And it's still bias. It's not only that you get the gender bias here, but you can also get, for me, if I say a picture of even if I say a female in the kitchen or a woman in the kitchen, I would imagine, let's say, my grandmother rather than a young lady, right? So it's still this kind. If you see also the age is very big. And then what you can do if you change some of these words, if you put now a picture of a chef in the kitchen, you are going to get, let's say, the male chef, which is of course strong bias because there are also female. And then all of a sudden, some new biases because now this kitchen looks more like a professional kitchen rather than a home kitchen that we had. Right, so the prompt is agnostic of this type of information, but still the model has some kind of underlying information that is in it. So what we want to do is, so this is a work that we had, we consider this as an open bias problem, in which you try to understand what kind of possible biases could occur given a particular prompt, right? So practically what we do, we take a set of prompts, we ask an LLM to tell us what kind of biases could be in there. It could be like person-related biases, whatever related to the objects and so on. Once you have this bias, I'm trying to generate some sort of captions that are related to that. So we use lava here. So you can try to understand. So for example, what is the race of the person? What is the gender of the person, the age, and so on. And based on that, I'm trying to generate new data so that I'm compensating for the bias that is in my training. And what this is another example. So if you have a small child hurrying towards a bus on a dirt road, you see, of course, it is a dirt road. The bus, it's almost missing all the time, but all the child that you get in there are black. And you say, yes, of course, because it's a dirt road. But you have dirt roads out in other places. So it is clearly. And another interesting part is here is that so as I said, that the kids also for the privacy reason are shown from behind. So you don't see. If you change now, let's say to put, instead of, you take out the dirt road and you just put running towards a bus on the road, then you get all white kids and now you get yellow bus. So you just discover new biases that you would not imagine, right? So this is probably because there are very compartments. So what we were looking into here, this is an extension of the work that Matapami just published in November, trying to look at the gradients of how each individual word will contribute to the final part. This is what we look into there. I don't go through details, but practically we are looking at the activations, and we can tell a particular word is going to contribute much to this particular part. Some final examples. So here you can look at, person gender, for example. So this is what we had before. But you can also have something like, for example, a guy riding a race bicycle making a turn. You get a lot of sportive guys. If you just change race bicycle with a broken bicycle, now you get a lot of leg guys. Okay, so they are not sportive anymore. So these are this kind of bias that we are looking at. Maybe another interesting part is if you look into a photo of a person on a laptop in a coffee shop.
Okay. Okay.
You see, for example, if you put it like that, you get
Okay. Okay.
in the lower row. If you put a teenager, you get a lot of Apple. Probably there is this kind of connection between the youngster and something.
Okay. Okay.
Okay, so just my last slide. It's what I think is important, and this is something that we should probably put more attention into it. It's how the user, how the customers are going to kind of provide the information, right? So the ability is important because the user care about it. Customization even more, right? Because we do want to generate videos that are meaningful. I just don't want to generate any video with any cat, with any. I want my cat, my dog, my wife, right? That will be. And then, of course, when we do these kind of things, we want to make sure that we are controlling, we are able to mitigate or even enhance the bias.
Okay. Okay.
Okay.
Okay.
Of course, you can have this guy. Well, it's sad that I don't have audio here, but that's important. Thanks.
Okay.